A lot of what I'm going to talk about today is more applicable for projects that are medium to large-scale projects that are more long-term, but I'm sure there are bits and pieces that you can use and apply for projects of any scale. My name is Premshree Pillai. I'm a senior engineer at Etsy. Before this, I used to work at Yahoo. I work on a lot of different kinds of the stack, from the front end and also a lot of the back end. Most recently, I've been doing a lot of React and also Go. So, Buongiorno. I am very excited to be in Bologna. This is my second time here. I really like the city. I like that it's small, contained, and wonderful food. How many of y'all have heard of Etsy? Quite a few don't know what Etsy is. So Etsy is a marketplace that buyers and sellers from around the world connect in order to sell and exchange goods and online. And think of it like if you go down a street with a lot of boutique stores or businesses, small businesses, it's an aggregation of all of these places online. So I wanted to give you a sense of the scale we are dealing with. So we have around 1.7 million active sellers, 28 million active buyers, little under $3 billion in GMS. GMS is gross merchandise sales, so that's the sales that happen through the various marketplaces in that year. And a little over 1,000 employees and 10 offices, 8 countries. We also have a lot of people working remotely from various parts of the world, primarily in the United States, but also various parts of the world. So today, I'm going to talk to you a little bit about the principles that guide our continuous deployment process, some of the tooling and culture we have in place, and also then we'll end up with Q&A. So principles. This one's a little obvious, just ship, but unfortunately, it rarely features in product goals, and when you don't actually call these things out, you don't actually know why you're building some of the tools when you want to enable continuous delivery. So calling it out, I think, is very critical. We want to be able to ship products. That's what we're here for. We want to be able to innovate. We are here to ship products in the end, not code. We want to be able to make these products quickly. And also, as ourselves, people who are developers or engineers or product designers, we have certain intrinsic motivators. So when we think of how we want to develop the continuous delivery tools we have in place, we want to optimize for purpose, autonomy, and mastery. So we don't want our continuous deployment tools to ever be a hindrance to any of the things we develop. And I think this is also critical in keeping in mind, because we're developing these tools to take away obstructions in our development. We don't want these to ever be a purpose in themselves. When we want to think of how we develop tools, we also want to keep experimentation in mind. We want to be able to develop products quickly. We want to be able to A/B test. So for example, if I have 2 versions of my homepage, I want to be able to test whether one version of the homepage does better or another one is doing better. So we want to be able to do that. We want to iterate quickly. Like products are never going to be 100%. There is no definition for perfect. But we can always make measurable improvements to what we are building. And so we want to be able to iterate quickly. We want to improve products in the end. We would rather fail fast than have stagnant code lying in our code base. And baked into all of this is the idea of continuous improvement. So like our continuous deployment tooling and culture should also help us improve the process itself. No process is going to be set in stone. We need to evolve with the technology we have. We need to evolve with the number of people we have. So our process that we have in place should reinforce that improvement also. I think we have a tenuous relationship with failure, and I think we assume that we shouldn't be failing when we have stuff on the internet or when we deploy our products. But the reality is, whether you like it or not, you are going to fail somehow. Sometime it will happen. So I think denying failure is not helpful. I think what we want is to optimize for the lowest amount of time to recovery. So we don't think of, we don't want to fail. We definitely don't want to fail. we would really like not to fail, but we will fail. So we want to optimize for mean time to recovery. So I'm just going to walk you through what a typical continuous delivery cycle looks like. A lot of us are familiar with this already. So a developer or designer commits code, which triggers a build, which leads to some test being triggered, and you do some user testing, and then you release, right? Each of these also has like a feedback loop. So if one of these steps fail, you can proceed ahead. The slides are looking very different. That's not what it's supposed to look like. That's what it's supposed to look like. I don't know why it was. Yeah, sorry. I know there was a display issue before, but I apologize because that makes more sense. So I'm going to walk you through a little bit of the tooling we have in place to go through each of these steps. So one of the things we do at Etsy is we do frequent check-ins. We do frequent check-ins to master. So I think when I say this to a lot of people, people think it's crazy, but it's really not. We use Git, we use GitHub, and I think one of the great features of GitHub is being able to branch very easily. And we do use branches in GitHub, but we do that within the team. If I send a pull request, someone may merge it in and then commit to master. But organization-wide, we commit directly to master, and I'll walk you through how this is working out for us and why we do that. We are able to do that primarily because we branch in code. We use something known as feature flags in order to branch. A lot of the tooling I'm listing here has GitHub links. Some of these projects are archived, but they're there for reference if you want to understand how they're built. So the feature flag is a very simple concept. Basically, we have a couple of configuration files where you for each feature that you're about to release, you basically tell whether it's enabled or not enabled. And so this is like what it might look like in the configuration file, but in your, and also you can, the feature flag also enables us to tell whether a feature is enabled for a percentage of users. So it's not just on or off, it can be enabled for like 1%, 2%. So here, it's saying this feature is enabled for 1% of all users. In the previous one, it was just off, and then the one before, it was on for everyone. And also, when I say a feature flag is enabled for 1% of all users, this is 1% of all cookied users. You can also enable it optionally for your users, so for logged in users. So I can say all logged in users 1%. And the way it works is across users, that same user will always see that same feature either on or off, so it's not arbitrary. And in your server code, the checks that you do look like this. It's just a simple is enabled check. If you wanted to check for if it was enabled for a certain user, there's an is enabled for. Now, the code I showed here is just like simple PHP. We also, of course, have apps, iPhone app, Android, iOS, and Android. A lot of our development is API driven, so like these calls can be made through HTTP requests. So similar to feature flags, they also enable us to do experimentation like I showed you before. So when you are enabling something for 1% of users, that's very useful in order to experiment. We can experiment with multiple variants of a feature. So if we wanted to test multiple versions of our homepage, for example, we can do that using the same feature flag. So earlier where I had a feature flag just on, I can now have it be on using different variants. So for example, if I have, in this what the code is telling us is layout 1 is enabled for 1% of users, layout 2 for 2%, and layout 3%, and layout 3 for 3% of all users. And in the code that you check whether a variant is enabled or not, you do essentially the same thing, but you switch on what feature you have enabled or not. So one of the advantages we have with, I was talking to someone else yesterday, and they mentioned one of the problems with feature flags is, of course, there's a lot of cruft built up. There's a lot of conditionals in your code. And cleanup is a problem, and the current process we have for cleaning these up is to, every week we we have a cron running that scans through all the configuration and checks for potentially stale configurations. Say a feature is completely on, chances are you don't need that if check anymore. However, that problem aside, this helps us iterate very quickly. We can just directly push to master because we have this. I think this is one of the things that enables us. It's also a combination of a lot of different tools that I'll also talk about, but feature flags definitely enable us to move at higher velocity very quickly. So all this boils down to continuous integration. Basically, whenever we make a commit to master, we want to keep the build green. These automated tests and that get triggered once you commit, in the end, our goal is that the build is always green. And we should be ready to release at any time. So one of the things we do before we commit to master is we use a tool called try. It's also available on GitHub. It's a Jenkins plugin that basically, when you run try, it sends the diff of your current working copy against what's on master, and runs the test using that diff. So basically, what this helps you as a developer is to build confidence in the patch you're pushing. And I'll talk about why you want to do this before and not at some later stage. It's an open source tool, also available on GitHub. So when you run try, it's basically, this is your normal Jenkins interface with all the different tests that ran. When you're ready to deploy, we use a tool called deploynator. Deploynator is also available on GitHub. It's basically a web interface that helps us deploy to production and our pre-production environment, which I'll get to before. It's called Princess. So you see two green buttons there. That's all you need to click in order to deploy to production. So the one below there. Once you're ready to deploy to production, there are automated tests that run on Jenkins. You come back to Jenkins, you check your status is looking good. You do some manual testing, of course, and then you're ready to release. It's already released. So that green button there, that's the only button you click in order to deploy to all our hosts in production. We have, so the deploy process I'm talking about is currently for the web stack. We also have a similar deploynator for the search stack, another slightly different process for mobile deployment, because it's a little more complicated with mobile when we have to get approval from Apple, etc. But it's similar. I mentioned deploying to production, but in reality, we of course have a pre-production environment that's, we call it Princess. It's basically a box in production that's depooled. So before we go to production, we go to Princess. We do some, there are automated tests that run on that environment. You do some manual testing there before you actually go to production. This process makes it very simple for anybody to push. Typically, there is a lot of fear around wanting to push, but so far we've not encountered people. I think the first day people are a little afraid when they click on production push, but once they get used to that, it becomes very easy. It's a joke, but a dog can push. So the idea around the way we have our continuous deployments set up is not that you should be complacent and push whenever you feel like. I think you need to be anxious. You need to have a healthy anxiety before pushing, because what you're pushing is going to affect a lot of people, millions of people. But you don't need to be afraid, because the tools and processes we have in place should help you gain confidence in what you're doing. Like, of course, traditionally, I used to work, I've been working in technology for a while, and I worked in environments where there's always been a handoff between developers and operations. Like, I build some code, operations goes ahead and deploys it to different, operations goes and deploys it to various boxes, and I don't know, but it may work, it may not work. I've worked in environments where I would work for on something for a few months, and it would get deployed 3 months later or 2 months later. I think that's kind of crazy to think about now, but I think in an environment like this, it makes like the interaction between developers and operations more collaboratory instead of being adversarial. So operations folks are more involved in building tools that help developers push instead of actually going and pushing out these themselves. In order to increase our velocity, we also have this concept of dark changes. So dark changes can be simple things like template changes, CSS tweaks, unreferenced code. There is, of course, we're putting trust in everyone to know that they're doing the right thing. These are code changes that basically you can just go ahead and push without going through the whole deploy cycle. Occasionally, someone may accidentally push code that's not actually supposed to be dark, and that creates a problem. But for the most part, I think most people have a good understanding of when it is okay to push or not. So, and by convention, we mark dark codes as dark. So when I commit something as dark, I would just mark it as dark. Just by convention, and then someone who is actually pushing the code at some later point while they're pushing, if they look at my commit, they know they don't have to worry about it. It's not going to create any problems. Similarly, for config pushes, so configuration pushes are separate from actual deployments because we don't need them to be blocking each other. They can happen in parallel. So for example, if a feature is enabled for 1% of all users and I want to increase it to 50% of all users, I can just make that configuration change and go through a different push cycle. So you're not blocking anyone else from pushing. So how do we actually push? We do this using IRC. So this slide is actually a little old. We recently, I forget how long, maybe 5 months, 6 months ago, moved to Slack. But before that, we used to use just IRC, which is, Slack is basically just that, but better. So whenever anyone is ready to deploy to production, also this is like a command line IRC client, just for fun. So when someone is ready to deploy to production, they join what we call a push queue. So what you see there up on the title of this is the title of the channel. It's basically telling me Amit and 4 other people are currently in the queue to push, and there's a separator there that's saying that ASM is in another push train. The star indicates that they're all ready in that current state. And Princess tells that currently they're on Princess, which is our pre-prod environment, during the deploy process. So say I want to make a push. When I'm ready to push, currently that's the topic on the push train. John is currently pushing. When I say I'm ready to push, I go to IRC, say .join. It connects. It tells me I'm now going to push with John. At any stage in the deploy process, when things are looking good for me, I say good. So for example, I commit my changes, then I say, okay, I'm good. Or in Spanish. And so it gives the asterisk mark. So when John also is good, he knows that we are both good and we can proceed to the next stage. So for example, the first stage is commit. So John will commit, he'll say .good. I will commit, I'll say .good. Then he will go to the deploy enter box and hit on push to pre-prod, push to princess. So now at this point, since our push train is already running, if someone else wants to push, if they click on join, they will get their own train. If none of us were ready at that point, they can join our train. We do this using pushbot. It's just a simple grammar, also available on Etsy. It's also an archive project, but I think it's useful to get a sense of how it's actually written and working. So at this point now you've deployed to your code to production. Now what? It's the time to gain confidence in what you've deployed. One of the tools we have for gaining confidence is supergrep. Supergrep is just a web interface for aggregating all the logs across all your boxes. It's also available on GitHub, another archive project. So this is what supergrep looks like. Basically, once you deploy to production, if there are any potential errors that may have happened from your push, they will start bubbling up here. The green that you see there is whenever we have made a deploy to production. So this is one way of, for us, before you even go to production, actually, you can go to Princess, our pre-prod box, and you can filter SuperGrep to show only Princess errors. So, and you do your manual testing and see if there are any logs, errors coming up in SuperGrep. And there are various ways in which you can filter these. There's also a tool called Super Top we have, so similar to MySQL Top, or sorry, just Top, where instead of showing you every error, it shows up all the top errors that show up. So then that's a great way for us to know, oh, something's different now, something's changed. Just an example log line there. We, of course, make extensive use of dashboards to know when things are going well or things are going wrong. We have deploy dashboards to begin with. Some of these graphs are a little old, but they're basically essentially the same thing. So we have system-wide graphs to make sure that no change that someone has pushed is causing potential problems. So for example, if the number of logged-in users go down or number of HTTP 404s are higher, we know something is potentially wrong. For example of a 404 graph, the vertical lines you see there are the push markers. So that's when a deploy actually happens. So you can look at the last deploy and the current deploy and get a sense of whether things have worsened significantly or not. Typically, there is a trend to all of these graphs, and so you know what to expect. Also, in addition to deploy graphs, there's of course application-specific dashboards. So each team, each project that builds their product has dashboards that have metrics that are relevant to their app. So for example, these are dashboards for shipping tracking on Etsy. So whenever a seller is ready to ship something to a buyer, they can add the tracking number, and we track USPS tracking, for example. So if something's wrong with the tracking system, we can pretty quickly understand if something's from a recent push caused it. We use StatsD and Graphite for this. Some of our dashboards are also now in Grafana, I guess. StatsD is also on GitHub. So to summarize some of these tools, the pre-flight check is what we use called try. Is basically now it might make sense that because the way we do pushes, we orchestrate pushes is through IRC. We want to make sure we try before we join that queue. So that's the reason we do try. It basically sends a diff of your working copy to what's on master and then runs those tests. When your tests look good is when you should join the push queue. If not, you should go back and check what's wrong. When you're ready to push, you typically join a push chain on IRC on Slack. And the person who's driving the push, the person who's ahead of the queue is the person who's the one deploying and going to deploy nader. So we use deploy nader. And of course, some user testing for verification, and dashboards help us gain confidence in the push we made. Anyone know what this is? Yep, it's a RJ45 Ethernet cable. How many ways can you plug this in? How many ways do you think you can plug a USB cable in? Both one, but the USB cable is not so obvious, right? The RJ45 cable is designed so that it's obvious how you should put it in. And it's basically called poka-yoke, mistake proofing in Japanese. And so I think the way I would describe our continuous deployment tooling and ecosystem is poka-yoke. Like, we want to make sure it's as difficult as possible to make a mistake. Mistakes are going to happen, but that's when you find something's creating a potential for making a mistake, we fix it. So in addition to tooling, I think the culture around the ecosystem is very critical to having an environment where you're actually able to deploy continuously, very efficiently. And the thing is, no one owns culture. Culture evolves, but you can set it up such that it creates a culture that is only beneficial to high velocity development and deployment. So some things to keep in mind. We always assume best intentions. It really doesn't help anyone if you point mistakes, because that's not helping you or them. We try to cultivate empathy. Like I think of how I'm a developer. I don't always know what it's like to be in operations. So I think if I get a sense of what it is to be in operations, or if I get a sense of what it is to be in support, so we do occasional support rotation. So like developers, engineers, product people, everyone goes to the support, uses our support tool and answers to like questions by email to buyers and sellers. I think this helps us understand what they are going through on a daily basis, instead of having siloed division of work where we can't understand each other. This helps us get a sense of how it is to be in each other's shoes. And of course, we want to be open, and we acknowledge that failure is an option. It's not that we want to fail. We would really prefer not to fail, but that's going to happen. But I think failure is also an opportunity to make our systems more strong, make our systems more resilient. To that effect, we do post-mortems. We take these very seriously. So when things go wrong, we meet, we walk through the timeline of everything that may have happened that led to this failure, and try to understand like where are all the potential holes that may have led to this. So I think it's not helpful to think of failure as a single root cause causing something to fail, but it's a systemic issue, and I think we can solve it better that way. And of course, these postmortems are blameless. It's impossible to lay blame on one person or a few group of individuals for something that went wrong. I think what goes wrong is often a system of something that may be lacking in the system overall. And from these postmortems come remediation tasks. These are just tasks that we know we need to do to make our system stronger and more resilient. We have a tool internally called Morg, which is basically like a list of all the failures we have gone through. And they're I think, often they're not that interesting, because they may be something very simple that went wrong and then the team fixed it or whatever, but often they're really interesting, and I think you can learn a lot from especially some of the more complicated failures that you can't quite figure out what may have caused it. They're interesting to go back and read through and get some learnings from those. So here, for example, it's funny, but Etsy, September 10th, Etsy is our lunch at Etsy. Something went wrong at lunch. So we did a postmortem on why. I think some people got sick after the meal or whatever. Yeah. Morg is also on GitHub, but it's just a front end that works well for us. We also have a 3-arm sweater award. It's the award for the most spectacular failure of the year. And to be clear, it's not meant to be a glorification of failure, because we are not trying to do that. It's awarded to the failure that from which we could have some of the most interesting or most or more complicated learnings from a particular failure. We also have a tool internally called Mixer. It's basically a tool that every week on Monday when you go into work, it automatically sets you up on a coffee meeting with someone in the office, engineering, design, whatever. It's an opt-in system, of course. I think this is really useful because, when I'm on push, we're a company of 1,000 people. There are many people I have never met, potentially. And if something goes wrong, I can say, hey, something's wrong with your tests, or something's wrong with the commit you just made. But if I've known this person, if I have some interaction with this person, it's very hard for me to be rude to them. You can't. I think this creates a level of empathy that I think is really positive. I think when you know someone, you're not going to just shame them, or you're not going to be rude to them. I think this really helps there as well. So to summarize, I think it's a combination of culture and tooling. It's not just tooling. I think tooling alone can solve problems. In the end, I think software is a human endeavor, and I think both of these together help us deploy fairly continuously and pretty well. Most often we succeed, sometimes we fail. When we fail, we conduct postmortems, out of which evolve remediation items that feed back into this cycle. And in addition to just failures, we learn from failures. I think that's a great mechanism in order to improve our systems, but also you need external stimulus. So you want to be aware of what's happening around the world. You want to be aware of containers, for example, if you want to make use of that technology to improve your system. So we need external stimulus. I think conference is an example of one way to interact with people in the world outside and gain more learnings. So we are able to deploy it pretty well and pretty continuously. We do around 30 plus at least 30 plus deploys every day, over 30 configuration deploys every day, and actually these numbers may have changed since there are more people committing now. Yeah, that's all I got. And codascraft.com is the Etsy blog. There's often interesting articles on relevant technology, so I urge you to visit it. But that's all I got.